This is the May 21 Examiner's Report for Chemistry Internal Assessment. You will find in this video that many things that have been said previous years have been acted upon, which is great, and some recurring things still keep happening. So hopefully this video is of some value to students and their lovely teachers. Personal engagement. Most kids, most students scored 1. Why do they only score 1? Because they're often still doing the glib. Since I was little, I've always wanted to know the enthalpy of combustion of hexane. No, you haven't. To get full marks, to get a 2, personal engagement is displayed, exhibited, curated even by taking a standard method, adapting it to suit your research question, doing lots of trials, recording lots of data, giving lots of references to show that you care deeply about your internal assessment. And it is a feeling that you get. It gets you to a level 2. A rushed, scant appreciation of the criteria will never get more than just a 1. And every mark is sacred, in my humble opinion. Exploration. Students are getting much better at exploration, or the teachers are getting better at describing about what is perhaps expected. So a good, highly focused research question with both quantifiable, independent variable and a dependent variable not only scores well in exploration, scores beautifully in analysis as well, and sets you up for a very high scoring analysis. The faults we can see there, I'm going to unpack them a little bit, or try to. Just a reminder, just stop doing categoric data. It's not going to meet the chemistry diploma IA criteria, nowhere near as well as a quantifiable linear trend. Overly ambitious research questions, going to cure well poverty, going to extract, what did we try last year? Extract limonene from citrus fruits by varying the dipole moment of the solvents, which sounded great on paper, but oh my gosh, that was far too ambitious to achieve in the 10 hours that is expected in the internal assessment. And that was one that I did as well. Okay, vague things like the efficiency or the the credibility or words to that effect, just vague English words about a scientific chemical principle, are not going to score well. How efficient is it to vary the solvent for the synthesis of aspirin, for instance, would not be a recommended good research question. As a reminder, brand checks. The school laboratory is never ever going to be as precise, accurate, validated, all these beautiful science words, as an industrial, pharmaceutical or food production facility. Don't flatter yourself, kids. Stop checking brand labels. You're not going to get that same level of accuracy as an industrial plant will get. Why? Because they have lots of money to spend on sophisticated machinery, which is calibrated by external people that come every year to do it. And you might not have an X-ray fluorescence spectrophotometer to work out the amount of calcium in a sample, but they do. So think about it. Make sure the chemistry is diploma level chemistry. And yes, titrations are in the diploma. And yes, they are in the GCSE. So make it something like a back titration, a redox titration. Explain the depth of the chemistry that you understand behind it. Not just a straight up sodium hydroxide, hydrochloric acid. No. General syllabus stuff, not specific to the IA. Many IAs we open, there's the Maxwell-Boltzmann distribution, there's the enthalpy diagrams, there's a pH's pKa at half equivalence point. It's all good if it relates to the internal assessment that you're doing, but too often we do see students just throwing chemistry at the wall and hoping some of it will stick and get them some marks. So what did the high scorers do? They used and they told the reader, the moderator, the marker, the examiner, what the calibration was on each piece of equipment that they used. They made calibration curves for colorimetry, for instance. Lots of repeats. They standardized their solutions against primary standards, recorded all uncertainties correctly with the right number of significant figures and decimal places. See my uncertainty video. Included capacities. So this is important. I've always driven my students to do this. I hope everyone does. It's not enough to say I measured 25.00 cm cubed plus or minus 0.05 cm cubed in a measuring cylinder. that's not enough to get you the marks. The correct way to get the top marks is I used a 0 to 50 cm cubed measuring cylinder. So put in the range of the equipment that you are using. Also use the correct glassware. If you're recording a volume accurately, you should be using a pipette or a burette, not a measuring cylinder. Safety, ethical, environmental was done much better in the May session. Clearly the message is getting through there. I will try and emphasize the database aspects, which clearly many schools have had to do. A lot of kids were describing a method as though they had done the experiment, which is fine, they've researched it, it's okay. But that's not going to score very well, because what the IB wants to see, according to the examiner's report, is they want to see why you chose to use, I don't know, SDBS Spectral Database or ChemCompute. So why did you choose those particular databases? What makes your choices more valid than if you had chosen somewhere else? If your research question is not clear, focused, contains a quantifiable IV and DV, independent and dependent variable, forgive my acronyms, your analysis is already doomed for failure. So high scorers had quantification of not just the dependent and the independent, but also the control variables as well. And the high scoring IAs had a little table saying, I said in my control variables and in my method, I'm going to control temperature. And this was the results for the temperature during my experiments, and I monitored it. And this is the proof that I monitored the temperature as my experiment was going on. Some students say they're going to monitor, they're going to control the humidity. Good luck with that. I live in Singapore, it's about 90% every day. Some students are going to control pressure. They want to see realistic control variables, not overly ambitious variable control. Uncertainty propagation, sig figs, decimal places, did put many students from a top band to a middle band. And for the top bands, you must show, and I know people are going to grumble, but it's in the examiner's report, significant numerical calculations with a graphical analysis in the discussion. There was too much of the just plotting the raw titer and not converting the titer to a concentration, or plotting the temperature rise and not converting that to an enthalpy. So just plotting raw data is not going to score highly in analysis. You need to do some significant numerical processing using calculations. So the weaknesses you can see here. Many students didn't record the control variables. It was just raw data. They just averaged all the data without considering or saying, was this an anomaly here? I've been writing number protocols on number of IAs because the number protocols are clear. They're in topic 11.1, measurement and data processing. There's no excuse for not knowing how to plot a graph, which you should have been doing throughout the course. Maybe even maximum minimum gradients, which are not in the report. This is just me. But systematic and random errors are in the examiner's report and are required for the top bands, and those are in 11.1, measurement and data processing. Incorrect description of graphical relationships, exponentials, inverse, direct, linear, all these words the kids should know and display they know what they mean in relation to their own internal assessments. And for database, I was very happy to see that the half-range method that I've been espousing for the last couple of years is sensible as an approach. Yay! Evaluation of the high scores, don't forget this is the IB, they want reflection. How did you describe your method? Did you just open a book and go, aha, that's how I get the activation energy for crystal violet with sodium hydroxide? Maybe. Did you consider different methods? Did you look in the store and see what you had? Did you weigh up the advantages and disadvantages of different approaches to answering your research question? A paragraph on that will get you a high score. When you're describing the outcome of the internal assessment, it must be couched with a discussion of the uncertainties. Many that I marked, the uncertainties were so big that the trend was eclipsed by the magnitude of the uncertainties. Although it was a nice linear line, the uncertainties were up here, and there was no way, if you looked at a maximum minimum gradient consideration, that there was any significance to what they found, and that scuppered their evaluation because they failed to recognise that. There needs to be a high level, a diploma level of chemistry. Forget all the standard higher level discussion. There is no standard and higher in internal assessment, but there needs to be a high level of diploma level chemistry when comparing with the literature value. It's a start to say it's 30% of the literature value, but why is it 70% different? That's what's going to get you the higher marks. We also need to say we're very good, apparently, at saying what was wrong, what was weak. I spilled something. Some solvent evaporated. There was a time lag before I put it in the colorimeter. All these things, these are all human errors. The human failed to do that. Okay, you've recognised it, that's honest. But talk about the strengths as well as the weaknesses. And as I've said it before on every video, systematic and random errors must be discussed if you want the high marks. High scorers looked at their method, reflected on the method, and suggested a better method. Not just, let's do more. Let's do more repeats. If I had more time, if I had better equipment, if we had more money. No, not going to get you a high score. Communication, pretty good. Most students got 3, I think. Top scorers, there's a nice, this is across the whole report. It's clear and concise. It's got loads of chemistry in it. There's no superfluous material that's not related to directly answering the research question. It's 12 pages long, and less people are being cute and doing appendices because the moderators are not required to read them. Decimal places, sig figs, your number protocols will mark you down from 4 to 3 to 2 pretty quickly. If you're inconsistent decimal places, significant figures, if you're not using SI units, IUPAC nomenclature, and your reference is not done correctly. But those are easy things, right? Just dot the I's, cross the T's, give yourself 4 marks. As I said, moderators are not compelled to read appendices, and I've tried to précis the examiner's reports because I don't want to break any copyright infringement with the IB, but that is almost word for word from the report. My apologies for copying that. So future guidance for teachers is secondary data is not just for pandemics. Yay! So we can use, they want, the examiner's report saying they want to see more secondary data. But don't forget to expand the DV and the IV. And again, look at my video on how to smash your IA, the pandemic edition, for more guidance on that. What's going to be the effect of increasing temperature on the rate of the reaction? It's going to increase. Everybody knows that. Reflection will perhaps be the main driving guidance, I think, from this examiner's report. Why did you choose the method? Include a paragraph on why that method was chosen. Now that's been in the last 2 years of examiners' reports. If you're not doing it yet, it's time to begin. Secondary data reflects on the approach on the sources. Well, I've mentioned this earlier in this video. Why did you choose that particular source? Why did you choose that database? And how does that better answer your research question than using something else? What have you excluded? Don't pretend you've done the experiment. Record all your independent variable data, your dependent variable data, and your control variable data. Control variable data table shows you care. Uncertainties, if you can't tell the difference between absolute and percent, and if you can't add them from different dimension variables, then you need to revisit them. Look at my uncertainties video. Stop doing title pages, indices, appendices. These are all discouraged with the adjective used in the examiner's report. And finally, annotations on submitted work, which is often a topic of discussion, do really help moderators support your decision and your marking. Okay, I hope you found that useful. Thank you very much indeed for watching. Hope you have a great day. Stay safe and well. Look after each other. Smash that subscribe button. Thank you very much indeed. Bye-bye.